Okay, guys, so solving by substitution when they're not both linear. When they're handed to you like this, obviously you're going to want to graph, but write these down just so you have them in your notes. Or maybe you don't want to graph, maybe you want to do substitution. But graphing would be very easy because they are in y equals form again. But for substitution, this is not too bad when they are written this way as well, because that means if this equation equals y and this equation equals y, then they have to equal each other. So you're just going to write them on either side of a set of equal marks. And then you're going to combine like terms and get everything on one side, because you do see it's a quadratic. And the only way to solve quadratics is when it's set equal to 0, and then either by factoring quadratic formula, or you could go back to graphing if you wanted to again to solve it. But at this point, we're just going to stick to the algebraic for notes' sake, okay? So we're going to move everything this way because I want to always try to keep that x squared positive if I can help it. So I'm going to move that 3x, negative 3x, and that's going to go with the 5x. Remember, this is a big brick wall. So if it switches sides, it has to switch signs. So if it was positive, it has to become negative. So if I write out every step, I'm going to have 2x because 5 minus 3 or plus a negative 3 is 2x. And then I need to move this negative 2 over. So since it's negative, I'm going to add 2. And I'm going to add it to the constant on the other side. And I end up with 0 equals x squared plus 2x, because these two cancel each other out. That's not a trinomial, so we don't want to do big star. The number one thing you should always remember 100 times over is there a GCF first? So looking at both of these, they both have an x in them. So I can factor out a GCF. So if I go up here and factor out a GCF, x times x gives me x squared, and then plus 2, because if I distribute that through, I end up back where I started with x squared plus 2x. So that GCF does work. This whole thing is equal to 0. So at this point it is in factored form. But we want to solve it. So we're going to take each factor. So that's 1 factor, 2 factors, and set them equal to 0. So x equals 0 and x plus 2 equals 0. This guy's already done. So we know that x is going to be 0. And then x plus 2 equals 0. We're going to subtract 2. And x is going to equal a negative 2. So when x is 0, it should work for both of them. And when x is negative 2, it should work for both of them. So if I plug that in, they should be equal to each other at that point. So 0 squared plus 5 times 0 minus 2. This basically cancels each other out. So your first equation, when I plug in 0, is going to give me a negative 2. When I plug in 0 in the second equation, so 3 times 0 minus 2 goes away, and I get a negative 2 again. So this indeed does work for both equations to make it true. And then if we try it with our negative 2, so negative 2 squared plus 5 times a negative 2 minus 2, it's going to give me a positive 4 minus 10 minus 2. So negative 12 plus 4 is going to give me a negative 8. So my first equation, when I use x as a negative 2, so the very first equation up here at the top, I get a negative 8. Now we just got to check at the bottom. So 3 times a negative 2 minus 2. It's going to be a negative 6 minus 2, and I do get a negative 8 for that one too. So this indeed is our solution again. And it can be written all the different ways, but solution set as a list would be 0 and negative 2. And then as coordinates, when x is 0, y is negative 2. And then when x is negative 2, y is negative 8. Because once you plug these in, this is a y equals, and a y equals, or y equals, and y equals. So once I plug in that value for x, my output y is going to equal negative 8, y will equal negative 8, y equals negative 2, and y equals negative 2. All right, that's your first example, guys.